If an undersea mission is too deep or too risky for human divers, researchers can send down a remotely operated underwater vehicle. And these ROVs are set to become a lot more intelligent at what they do. The Janus research vessel is about to leave the port for a day at sea. It carries a piece of technology often used to observe or manipulate items on the sea floor. It's a pressure-resistant robotic platform tethered to the ship by a very long cable.
Humans can't go beyond a certain depth. If we want to get below 700 meters, then we need a robot. That's when we use the so-called ROVs to perform these kind of deep-sea operations.
Und da werden dann diese sogenannten ROVs eingesetzt für solche Arbeiten.
This vessel's ROV has two cameras, which, just like human eyes, provide stereoscopic vision. And with advanced arms, the manipulators have 3 fingers, so more dexterous than typical 2-finger ROVs.
There's some room for progress in terms of dexterity when manipulating objects. We're also working on controlling this kind of robotic platform via satellite link from a control center that can be placed anywhere in the world.
Until then, all ROVs need to be controlled from the ship. Moving the control onto land would be safer and more cost-effective because smaller vessels could be used. For the test, this ship in the Mediterranean Sea is linked via satellite to the control center in Belgium. Here, the operators work in a virtual reality simulation. Their commands are relayed back to the ROV. There's a slight communication delay, so the ROV has to be autonomous enough to operate safely with no real-time control, and it needs intelligence to act accordingly in the sea.
We've separated what the robot does from what the control center does. Here, the work will be conducted continuously in real time. The intelligent software will be observing what we're doing at the control center and will be sending this information to the robot, which will be carrying out the tasks automatically by itself without our continuous guidance.
To make robotic arms more dexterous, engineers in this European research project are using an exoskeleton system. It provides the operator with force feedback, allowing to feel the weight and resistance of the objects manipulated in virtual reality.
We'll control this 3D character in virtual reality. He'll perform a task, and his movements will be taken apart to be reassembled by the remote robot, which allows for operation with long delays.
This technology can help to control autonomous vehicles safely and accurately, not just in depths of the ocean, but also on land or wherever robotic dexterity could be used.
You can imagine the same kind of technology used on mobile platforms on the ground with manipulator arms. This kind of technology could be useful in dangerous situations such as Fukushima, where there's still the need for operations on the ground.
The researchers are testing components of their advanced ROV system, heading to an advanced trial deep in the Mediterranean Sea.